Hello. We're going to talk a little bit about cybersecurity and enterprise risk management. It's a very interesting thing to know because at the end of the day, cybersecurity, because it's always hiding in the background, right, protecting you. It's difficult to convince business people to invest in cybersecurity because if they can't see it, if they can't understand its impact, they won't really know what to do with it. So your job is to convert cybersecurity to enterprise risk because enterprise risk has a financial element to it. If you can convert cybersecurity issues or cyber threats into risks that matter, then what happens is you're able to convey what you need to convey much better. So understand that typically there are multiple roles. You have the security operations centers, they assess security failures. Their job is to understand people issues, process issues, and of course technological issues. Then of course you have the IS management chaps, right, whose job is to manage risks and policies. You have analytics people, where and how to observe detection mitigation patterns. Think of DevSecOps, right? So the security operations in the development process. Emphasize on understanding that you need to secure technologies by design, secure business processes, and secure people. At the end of the day, it's joint decision making. It's important to realize that at the end of the day, you are impresarios, right? You're conductors. You're not functional technicians. So you have to think beyond the black box of technology. This is why it's important to understand that you have to bring in managerial thinking, processual thinking, technological thinking, and people thinking to truly practice cybersecurity to reduce enterprise risks. So common areas, how do you typically use? Here's an example. Common areas, IS management and cybersecurity. They oftentimes, your job is going to be developing, implementing, monitoring cybersecurity strategies for compliance, legal, regulatory obligations. You'll analyze and communicate information security violations and program gaps, which is basically gap analysis. This is what we want it to be. This is where we are. How do we fix the problem? Can we find the root causes? So it's a part of, then once you have understand the gap, then you can do a root cause analysis to figure out the issues. Then you identify security requirements across systems and processes to reduce risk exposure and create remediation plans for vulnerabilities identified during risk assessments, audits, and inspections. On the other hand, the cybersecurity risk management, people will try to do risk framing. They'll define the context for risk decisions, including the scope, timeline, asset inventory, right? If you don't know what you have to manage, what you have to protect, that's why you need to have an inventory of sorts. And then identify threats, identifying current cybersecurity risks, threats, and vulnerabilities. Analyzing and evaluating threats, which is analyzing and evaluating threats based on potential impact. And addressing threats, which is IS security policies, incident response plans, and you have to figure out how to do that in a timely manner. So we've talked about the IS management part, the risk management part. Now we go into cybersecurity analytics groups. They use a series of different models like decision tree algorithms to detect and classify attacks. They use things like dimensionality reduction algorithms. If you've got many different dimensions, a lot of noisy data, you reduce that into things that matter, right? Very much like compacting them into placeholders. K-means clustering to detect malware, which is operating in a slightly different way, doesn't work within a single type of whitelisted cluster, but a non-whitelisted cluster. K-means neighbors classification, or KNNs, used for facial recognition, authentication, especially with deep fakes and so forth. Linear regression, you're trying to figure out how to predict outcomes, right, by looking at historical data and then extrapolating it to predict something. And then logistic regression is when your final objective is either a 0 or 1, yes or no. Was it attacked? Wasn't it attacked? Did the system fail? Did that not fail? Did the passwords match? Did it not match? So when you've got a model where the outcome is 0 or 1, then you want to predict using a regression model, it's a logistic regression. So your job is oftentimes going to be working. So this is typically when you go join a company, is to work in a collaborative, analytical, critical reasoning, innovative scenario planning based on understanding emerging technology threats, tying them to explicit risk management frameworks such as NIST, NCSC, BitSite 7, and then of course reviewing variety of white papers and so forth. And we'll now move into introducing why cybersecurity matters in the ERM scope, understanding the scope and focus of each, and exploring the key differences between cybersecurity and ERM in terms of frameworks. So, risk versus security, is it elementary or is it simply obfuscating? So the relationship between risk and security is such that security can really create a headwind, right? Or security breaches can create a headwind that can reduce a company's financial profits because it increases the risks, right? On the other hand, if you have good security, it can create a tailwind and can reduce the risks and therefore increase financial profits. So therefore you have to realize that there's an importance in balancing security and access. If you stop everybody from accessing things, then of course it can become secure, but it might not always be very convenient. Then of course you can have complex security measures, but then if you make things overly difficult, people are going to find a way to bypass it. And of course understand that AI could provide a headwind or a tailwind. It could help you or it could really hurt you. And of course tie in to understanding what how to connect the dots together. So comparison between cybersecurity and ERM, what are the differences? Again, cybersecurity is a way to reduce risk. Risk at the end of the day impacts a company's bottom line. They need to therefore work together and they need to be integrated very well. So cybersecurity primarily focuses on technologies, which are technical controls for digital assets and infrastructure, including data, of course, processes, how the data is delivered and how we typically operate. Think of standard operating procedures or SOPs. And then of course people, how do human beings interact with technologies and processes? ERM on the other hand encompasses a broader range of risks. You have to figure out strategies tailored to specific risks. What happens if this server goes down? Who will it impact? What kind of loss might we have? Broader set of regulations and standards. Will this be a violation of certain regulations? Will it be GDPR issues? Would these violate some kind of a compliance issue? Will we be fined for that, right? Will it suddenly stop us from operating in a certain degree, right? And then long-term focus. ERM has a longer term focus than cybersecurity. So cybersecurity is a shorter term, much more focused on just assuring your IT and data are secure and you can avoid threats as much as you can. ERM is the final objective in order to reduce risks. So one of the most important ones is called the NIST Risk Management Framework, or NIST RMF. So what are the essential activities? The essential activities in a risk management in the NIST Risk Management Framework is first, prepare, categorize, select, implement, assess, authorize, and monitor. You start off by preparing. So prepare the organization to manage security and privacy risks. This is where you need to communicate requirements, what are the common set of controls you need to use, and how do you reduce complexity. Remember, complexity is dangerous because complexity increases risk because it decreases security. Once you prepare the organization, this is a part of your planning phase. Then you start categorizing the system and the information that's processed, stored, transmitted on an impact analysis. You start looking at, if this were to be hit, what would be the impact? That's impact analysis. So start examining the adverse impacts of processes on the CIA triad, which is confidentiality, integrity, and availability. Confidentiality ensures privacy, right? And of course, requires encryption. Integrity ensures data accuracy and that it hasn't been tampered with. And availability ensures accessibility by the right person for the right person at the right time. So of course, then once you're prepared and categorized, you then go on to selecting the set of NIST SP 853 controls. So now you're going to select the controls. What kind of controls do we need to protect a system based on risk assessments? Then you know, once you've selected the controls, then you start implementing the controls. And then you document how the controls are deployed. Once you've implemented it, then you start assessing, are the controls in place? Are they operating the way you want them to? And are they producing the desired results? So which means you try out different scenarios to break the controls. If you can't break them, then you know that you're assessing them to be working properly. Then of course, a senior official makes a risk-based decision to authorize the system. So you now say, let it run, right? You're authorizing it, you're deploying it properly. And then you constantly monitor it to ensure that the implementation is done properly, to control it, and to also control the risks in the system. So let's start looking at these things in a little bit of depth. Let's start off with prepare. So in order to prepare, what are you doing in your preparation phase? You're communicating requirements, common controls, and you're reducing complexity. What's the purpose? Your job is to carry out essential activities to help prepare all levels of the organization. Remember, cybersecurity and risk management are enterprise-wide things, not just IT roles, to manage its security and privacy risks using the risk management framework. What are the outcomes? Key risk management roles are identified. You establish a risk management strategy and find out what is your risk tolerance. How much risk are you willing to tolerate? Of course, if it's healthcare, risk tolerance is very low. If it might just be somebody selling, I don't know, falafel, and that there, risk management might be slightly higher. Organization-wide risk assessment. Then you do a risk assessment across the organization, come up with a strategy for continuous monitoring that you can develop and implement, and identify common controls. Next is categorize. Once you're prepared, you categorize. What are you doing in your categorizing? You're examining adverse effects of processes on confidentiality, integrity, and availability. What's the purpose? The purpose is to inform organizational risk management processes and tasks by determining the adverse impacts with respect. What is going to happen? What are the adverse impacts in terms of the loss of confidentiality? What happens if the information falls in the wrong hands? What happens if somebody tampers with this, which is integrity? What happens if somebody else is able to access it that shouldn't have? Availability, and the information processed, stored, and transmitted by those systems. What are the outcomes? Here you start documenting system characteristics. You start completing security categorization of the system and all types of important information that you need. You oftentimes classify this information based on information priority and information sensitivity, as well as a combination of both, and then categorize decision reviewed or approved by the person who's going to authorize it. Next, after categorization comes selection. What's the purpose? Here you select, tailor, and document the controls necessary to protect the system and the organization commensurate, so in line with the risk, right? So there's a correlation. You have to come up with the right controls, the right amount of customization or tailoring, and the right amount of documentation based on how much risk there is. What are the outcomes? You create control baselines that are selected and tailored. Controls are designated as system-specific, hybrid, or common controls. Common controls would be everybody uses it. So controls allocated, here you also allocate controls to specific system components. So you might say a specific system would have a different set of controls compared to another type of system. Right? So you might say a credential management system would be very different set of controls, right? There it has to be very, very tight controls, right? Versus maybe somebody who's updating a specific public-facing website might have different controls. Then, of course, you have to do a system-level continuous monitoring strategy that you have to develop, and then come up with selecting the right security and privacy plans. Next comes implementing it. You're implementing the controls now in the security and privacy plans across the whole systems, all the systems and all the organization. What are the outcomes? You're trying to specify exactly what controls have been implemented for security and privacy plans. Update the security and privacy plans periodically to reflect the controls as you've implemented them. Then comes assessing. Assuming that you've put in the controls and you've implemented them, you need to determine, are they working the way we want them to work? Are they operating as intended? Are they providing the desired outcome? What are you trying to get at? You try to figure out who the assessor and the assessment team is, right? And then understand if the development plans, the plans for security and privacy assessment have been developed properly, if they've been reviewed and approved, if the controlled assessments are conducted in line with assessment plans. If there's misalignment, you're creating a problem because you might be out of compliance. Security and privacy assessment reports, how to do that and develop it. Make sure you have the remediation actions in place in case the controls don't work the way you intend them to, or you intended them to. And then security plans, update them to look at every single changes. As the environment threats change, you need to change that too. Come up with a plan of action and come up with milestones that you need. Then comes authorization. Now that you've got things tried out, implemented, you've started looking at if they're working properly, you now need to assign accountability and deploy them by requiring a senior official to determine if the security and privacy risks based on the operation of the system and common controls is acceptable. What you're doing now is the outcomes are as follows. You come up with an authorization package which includes an executive summary, system security and privacy plan, assessment report, plan of action, milestones, render risk determination, provide risk responses, and ensure that the authorization is approved or denied based on your authorization package, risk determination that you've rendered, and the risk responses that you provided. Finally, it's time to start monitoring it, because you can't just let something go and not look back at it. You need to audit it from time to time. You're trying to maintain ongoing situational awareness about the security and privacy posture as trends change, technologies change, secure threats change, and then the outcomes for that is constant monitoring of system and environment based on your continuous monitoring strategy, ongoing assessment of control effectiveness conducted in accordance with your monitoring strategy too, Output of continuous monitoring activities need to be analyzed and responded to. And then make sure you have the processes in place to report security and privacy posture to management. And then, of course, ongoing authorizations conducted because of monitoring, right? As monitoring changes, if things are found to be problematic, you might need a different set of authorizations to return back to the drawing board and institute everything again from the preparation phase. Next we talked about the Enterprise Risk Management Framework, or the Risk Management Framework, RMF. Now we go into NIST also has a cybersecurity framework. We'll show you how there's slight differences between them, but also a lot of commonalities. So cybersecurity framework is a CSF. So this cybersecurity framework relies on the following. What's the role of that? It helps organizations understand the cybersecurity risk, which is threats, vulnerabilities, impacts, and how to reduce these risks with customized measures. The steps there: govern, identify, protect, detect, respond, recover. Right? So what is governance? You're basically trying to come up with a risk management strategy. Expectations and policies are established, communicated, and monitored. So that becomes a big part of your risk management framework, or that goes into your risk management framework. Then you identify the organization's current security risks. You understand that. But of course, looking at your inventory and assessing that and knowing what controls are in place and safe. Then you start protecting, again, very much like controls, safeguards to manage the organization's cybersecurity risks. Then you detect. You try and figure out if there have been breaches, and there are ongoing breaches, possible cybersecurity attacks and compromise that are found and analyzed. Come up with a response set, actions regarding a detected cybersecurity incident, which is a part of your incident response plan, also called a playbook oftentimes. And then recover, which is how do you recover assets and operations that were affected by a cybersecurity incident to restore them and maintain business continuity, which is a part of your BCP or business continuity plan. So govern is where you start. You understand and assess specific cybersecurity needs, come up with a tailored risk strategy, define risk management policies. This ties in heavily with the risk management framework. Develop and communicate organizational and cybersecurity practices. Establish and monitor cybersecurity supply chain risk, which basically means the way a software or data is delivered from one place to another is a software supply chain, right? Or a data chain. And you have to figure out, can that data be hijacked through any middle points throughout the supply chain, and how do you secure it? And of course, implement continuous oversight and checkpoints. Next is identify. Identify critical business processes and assets. If you can't identify, you don't know what to protect. Maintain inventories of hardware, software, services, and systems. Document all your information flows. Where's the information flowing? Who does it go from whom to whom, right? Or from whom to whom? And then identify threats, vulnerabilities, and risks to assets and the data, and talk about the lessons learned to identify improvements. Then you go into protecting them. Once you've identified, then you can start protecting them. How do you manage access so people can get the privileged set to a specific bit of information? This is also a part of POLP, principle of least privilege. Learn how to train users by protection. Oftentimes, human beings are the weakest links. Protect and monitor your devices, protect sensitive data, manage and maintain your software, and then conduct regular backups and updates, patch management, update management, configuration management, among many different things. Then the next one is detection. Here you're trying to detect by monitoring network systems and facilities continuously to find potentially adverse events. You determine and analyze the impact, estimated impact and scope of adverse events. If something happens, a threat, an attack, a hack, a ransomware incident, what is the impact and the scope? Provide information on adverse events to authorize staff and tools. This is a part of your detection. Something seems to be anomalous. Figure out what it is and figure out what to do with it. Then what to do with this is your response part. So execute an incident response plan or an IRP once an incident is declared. This again is a part of something called a playbook. What do you do if something happens in coordination with relevant third parties, oftentimes the government, federal agencies, the regulators and so forth. Categorize and prioritize events and escalate or elevate as needed. Collect incident data and preserve its integrity and provenance. Provenance is where did it come from? How do we know this is the right data we have? Does it actually come from a trusted source? Notify internal and external stakeholders of any incidents and share incident information with them, following policies set by your organization, and then contain and eradicate incidents. Get back into operation. This is your recovery. Understand the roles and responsibilities in the recovery process. Execute your recovery plan. Is it coming from a backup? How do you know that backup is current? Can it be trusted? Can it interfere if you've suddenly changed something or reconfigured a particular system? Double check your work and then communicate with internal and external stakeholders. So here's a food for thought for you. How do you balance this risk? If you know something, it's risk. If you don't know what's going to happen, it's uncertainty. How do you prepare a company to be secure and manage its risk in the face of uncertainty? How do you differentiate between risk versus security? And of course, keep in mind that lower the security, greater the risk, right? There's an inverse correlation with them or between them. And then risk versus continuity, greater the risk, lower the continuity. So keep those things in mind. Thank you.